All right, today we're diving into something from Meta that is straight out of science fiction. We're talking about an AI that doesn't just process information, it's being designed to predict what your brain is going to do next. So let's break down how that's even possible.
So let's just get right to it with the big question. Can an AI look at the same thing as you, hear the same sound, and actually predict the super complex pattern of neurons that are going to fire inside your head? It's pretty wild to think about. We're basically talking about a bridge between machine code and our own biology.
So how close are we really? Well, a whole new frontier is opening up. One where an AI doesn't just, recognize a cat in a photo, it actually anticipates the intricate little fireworks display that happens inside your brain when you see that cat. And the piece of tech at the center of all this is a really powerful model from Meta called Tribe V2. What it's essentially doing is learning how to create a working, digital copy of our neural processes when we see or hear things.
Okay, so how in the world does something like Tribe V2 pull this off? Well, it's not just one big chunk of code. It's actually a really clever three-stage system.
The best way to think about it is like an intelligence agency. First up, you've got your specialists, the encoders. Each one is a master of a different language, right? One for images, one for audio, and one for text. Their job is to translate what they see or hear into a common format. Then you have the transformer, who's like the project manager. It takes all those reports and pulls them together into one big unified briefing. And finally, there's the brain mapping module. This part takes that complete picture and learns how to connect it directly to the patterns of a real human brain.
Now, what's really key here is that Tribe V2 isn't starting from zero. No way. It's built on the shoulders of giants, using powerful AI models that are already experts. For text, it's got LLaMA. For images, VJPA. And for audio, Wave to Vec. So it already has this massive head start in understanding the world before it even tries to figure out the brain.
Okay, so the AI can build this really sophisticated understanding of an image or a sound. That's cool. But how does it learn to map that onto the complex, kind of messy, biological reality of a living, breathing human brain? The whole goal here is to get a perfect match. See, when your brain sees a picture of a dog, it creates this totally unique electrical signature. The AI is trained to create its own internal digital version of that dog that perfectly mirrors your brain's pattern. It's all about building a functional bridge between silicon and neurons.
To do this, scientists use fMRI scanners, and the key thing they're measuring is something called a voxel. The easiest way to think of a voxel is as a tiny 3D pixel. Each one shows the activity in a small cube of your brain tissue, and when you put millions of these voxels together, you get a full map of what your brain is up to.
So here's how they put it all together. A person lies inside an fMRI machine while they're shown an image. The scanner records the exact voxel pattern that image creates in their brain. At the exact same moment, the AI is shown that same image. Now the AI has a puzzle. It has to tweak its own internal network over and over. We're talking thousands of times, until the pattern it generates for that image is a perfect match for the human's fMRI scan. It's literally learning the brain's language through a massive game of trial and error.
I mean, this is all just fascinating from a technical standpoint, right? But let's zoom out a bit. What does building something like this actually mean for us, for science, and, for the future? The potential here is, well, pretty profound. For neuroscientists, this is like getting a brand new window into how the brain organizes information. For AI developers, it's a blueprint for making models that think and see more like we do. But the truly game-changing stuff could be in brain-computer interfaces. This tech is a huge step toward a future where we could translate thoughts directly into speech, maybe even give a voice back to people who've lost theirs.
But maybe its most mind-blowing feature, the one thing that takes it from being just a clever copycat to something way more powerful, is this concept called zero-shot generalization. This is where the AI really takes a leap into the unknown. What this means is the AI can accurately predict your brain's response to something it has never been trained on before. So imagine it's learned from photos of dogs, cats, and birds. You could then show it a picture of an armadillo, an animal it's never seen in its life, and it could still generate a scarily accurate prediction of the fMRI pattern your brain would make. It's not just memorizing things, it's actually learning the fundamental rules of how our brains deal with brand new information. Which, of course, leaves us with a pretty deep question. As these AI models get better and better at mapping the physical brain, are they sort of accidentally starting to map the mind?
I mean, when a machine can predict our neural response to something totally new, it starts to challenge our whole definition of thought. That line between the brain's mechanics and consciousness itself, well, it's getting blurrier than ever.